Hey, my name is Bilal, and here in this course I'm going to take one of the important topics of the organic chemistry, and I've seen that most of the students struggle with that topic, and that is isomerism. This is one of the important topics of the organic chemistry. Hope you understand all the concepts very clearly. Let's take the first topic here in the isomerism. We know isomers are different compounds having the same molecular formula. And isomers, we first categorize them into two categories: structural isomers and the stereoisomers. In the structural isomers, the structure of a compound is different, or we can say the sequence of atoms or the groups in a molecule is different. And in stereoisomers, the relative position of atoms is different. So structural isomers have different names. When you start an IUPAC nomenclature system, if you get a different name for a structural for two different compounds having the same molecular formula, it means that they are structural isomers. However, in the stereoisomers, the IUPAC nomenclature system will be same. The two compounds having the same molecular formula, and when you start naming them, the name will also be the same. The only thing is some prefixes will be different, like cis and the trans. Those type of things will be there in the stereoisomers. So in short, stereoisomers are those compounds having the same sequence of atoms in a molecule, but the relative position of atoms, right? The relative position of atoms will be different in stereoisomers. Stereoisomers are of further two types: conformational isomers and configurational isomers. So conformational isomers are the isomers which get interconverted at room temperature. So some of the stereoisomers can interconvert of their own at room temperature. They are the conformational isomers. While as configurational isomers are those isomers or those stereoisomers which do not get interconverted at room temperature of their own, right? Because they need a lot of energy to change one stereoisomer into another. That amount of energy is not available at the room temperature. So technically, the conformational and the configurational, the basic difference there is that if you have an isomer, a stereoisomer that you can interconvert, that gets interconverted at room temperature of their own, it's a conformational isomer. And a configurational isomers are those which do not get converted into the room temperature from one isomer to the another isomer, right? Suppose we have a cis and the trans. The cis cannot get interconverted into the trans isomer, right? And again, the configurational isomers are of further two types: the geometrical isomers and the optical isomers. Structural isomers, they have different types, and we will discuss in our next coming videos about all these different types of isomers in detail. I'll take first the structural isomers, and after that conformational isomers, and then the geometrical and the optical isomers at the end. Hope you enjoyed the course. Thanks for watching the video. Bye for now.